Hello, my name's Bob Willis and welcome to Defect of the Month. Every month I try and provide an example of a particular defect and hopefully some solutions. And I've made over 100 different defect videos over the years, so hopefully one will solve one of your problems. Remember that if you like this video content, please subscribe to the channel. If you like this individual video, then just like it. And of course, please share it with some of your other engineering colleagues within your company. Wave solder skips or skipping. Sometimes some people refer to this as insufficient solder, where there is no solder on one joint or two joints on a board after the wave soldering process. But really, there is a difference between no solder and insufficient. Insufficient means there's not enough, so there's obviously something there. Anyway, so skips. Now, skipping can occur on products that are wave soldered, particularly when we're talking about surface mount components that are bonded to the surface of the undersurface of the board using adhesive and soldered during passing the board through the wave soldering process, possibly as part of a mixed technology design. And when we say skipping, we're talking about any pads, or in fact in some cases test pads, that have got no solder present. So you might find that on chip components, SOT23s, SOICs that have been through the soldering process, there's a few pins with no solder on, or there is no solder on the pads. And it's important to look in detail where the solder is or isn't, because that can give you an indication of what the problem might be. So, what are the reasons? Well, first of all, incorrect pad design. If there isn't sufficient area for the solder to wet as the board goes through the process, then again, a joint may not be visible. You might get a situation where there's a difference in solderability or wettability on the surface of the pad material that you've selected for your PCBs. So again, really, truly speaking, this should be a random problem across the whole of the board. But if you see skipping, unsoldered joints on just certain components, then it's perhaps more likely to be related to the design of the pads on that particular part. Now, if we look at what we would normally wave solder in terms of SMT, there would be chip components, there'd be SOICs, possibly QFPs, but less likely today, but also SOT23s. Now, as an indicator to me when the process is going or drifting out of control, if I've got boards that have got SOICs, SOT23s, chip components, the first component which is going to give me a problem when the process is changing, going out of control, or some other factor is coming into play, it will be the SOT23s. So those are the ones that will show you the skips first, and then you'll see it on other parts. So if we then start to think about, what is a contributing factor? Well, I've already said the pad size, but also the solder mask and the solder mask aperture and the solder mask thickness. Now, very rarely do any design engineers actually specify the solder mask thickness requirement and the variability of the solder mask on the surface of a printed circuit board. So if you can imagine, if you've got a pad and you've got solder mask around it, and that solder mask increases in size, i.e. thickness, that you're actually creating a barrier around the pad, which makes it difficult for the solder to actually get to wet the termination as well as the pad. Also, with very thick solder mask or variations across the printed circuit boards that you're processing, flux can actually sit within that cavity, because remember, the solder mask is sort of a cavity which is turned upside down, so you've got a bucket around the termination you're trying to solder. So volatile material can actually gas out from that surface because the flux cannot be displaced very easily from the surface of the board. So something to look out for. Excessive flux to start off with. If you put too much flux on, you've got to dry it off, evaporate the solvent as part of your preheating process. Thank you very much for listening to Defect of the Month. Hopefully it's been useful and possibly you've found a solution to one of your process problems. So just a reminder that if you want to listen to more Defect of the Month, subscribe to our channel. If you just like this individual video, then please like it. And of course, share it with some of your colleagues in manufacture and in other companies. It all helps to bring information to both production and engineering staff. If this short introduction to this particular problem was of interest to you, then of course we can hopefully provide you a solution to aid you eliminate more process defects within the future. Finally, if you've got a defect and you'd like it covered in a future Defect of the Month, then let us know. Thank you very much.